Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video is something I haven't done in a little while. We're going to repair some Commodore 64s. So without further ado, let's get right to it. Alright, so this is not a 64 here that needs any repair. This is my good old ZIF 64, and wow, the bottom of the keyboard sure gets warm from these ICs in here. Woo! When you have the cover on, even when you have heat sinks, it overall is really hot. The reason why I had the ZIF 64 on the bench is to double check that the power supply is good and my capture setup, because I've been having a lot of problems with the capture. But with my new Dell T1700 desktop, I'm able to successfully capture video once again. All right, for troubleshooting today, we're going to be using the double-ended dead test / diagnostic cartridge. And yeah, I had to Dremel away the case because I ended up needing to replace the EPROM. And the only way you can put this case back together with the EPROMs in is if they're soldered directly onto the PCB. We'll be using the virtual bench. So I have the oscilloscope probe right here. And we'll be using the Easy Flash as well if I get the system working and we need to run some dance party maneuvers. All right, here is the first motherboard we're gonna be looking at today. I actually don't know how many we're gonna be looking at. It's gonna depend on how much work they are to fix. Obviously here we have a short board, and I wrote bad RAM with a question mark. This would be a fully populated NTSC short board. This is from later 64Cs, of course, and it came from Michael Orange, which is one of my viewers. This was sent in for a mini mail call or a regular mail call, I don't remember. So on this version of the 64, there are 2 RAM chips, and the one on the left here, I put a little mark on there. It's one of my question marks. Most likely because when I power this up, and I'll power it up right now, I think what I found is that chip was getting really hot very quickly. So let's let this run for a moment here. It would definitely be causing a black screen if that's the case. Okay, let's see here. Just use your fingers. Yep. Okay. This RAM chip is fine, and these other chips around are fine, but that one, very warm. Okay. So first thing we're gonna do is we're just gonna pull that out of the board. There would be no circumstance, no matter what's going on this board, that would cause one of the 2 RAM chips to be that hot. Now that we flip this board over, there's some telltale signs that both of these RAM chips have actually been swapped out at some point. See the little bit of flux residue that's here on both of them? That would definitely not be there if these were the original factory installed chips. I gotta say, I find that kind of rude if someone did swap these out that they didn't install sockets, because this would have been like a 2-minute fix if that was the case. And actually check it out, 1987 date codes on the RAM chips, while all the other chips in this machine are 1989. So that's when this computer was built at the factory, and yet someone installed these older RAM chips. That in and of itself is not a problem. It's just the fact that they didn't even bother with the sockets. Okay, the bad chip has been replaced by a socket. Let's just grab one of my tested chips that I know work. I'll stick that in here. Boom. And hit the power. Boom, there it is, working. Why don't we go right for the 8-bit dance party here. Power that on. Look at that nice, clear image. I plugged in the ZIF 64 keyboard, and here we go, 8-bit dance party. Oh, that was anticlimactic. I have the speaker turned down. Okay, so obviously things are working. At least they're able to run this demo here. The SID on this thing, of course, works well because the SID's on this generation of 64 are very reliable. I've said that many times on the channel. The thing is, they sound a little weird, and you might notice on the music there, I had been doing an audio capture. The bass line is a bit strange, and that's not a fault. That's just because the SID is quite different than the one from the old machines, the 6581. So it just goes with the territory. But this particular SID is in more of these 64Cs. I'm gonna say out there in the world, there are more 64Cs that probably work, especially over in Europe where they were selling these machines a lot more than they were in the US. So I think a lot of modern games and demos are actually designed with the sound of this SID in mind and not so much the old one. But you know, obviously it's compatible. They're both compatible with the same software. They're not interchangeable between the machines though, but the sound is a little bit different. Okay, it's time to break out Sven Petersen's diagnostic harness here. Let's pull out the Easy Flash. We're gonna be popping in the regular diagnostic cartridge here. Now let me mention that if you are repairing your own 64, you don't need the diagnostic harness like this. This is really for someone like me who tests a lot of 64s. You can of course test the ports on your 64 by just using them. Plug in a joystick, plug in a disk drive, plug in a tape drive, just use those things. And if they're working and your 64 seems to work properly, then there you go. This is really just a very fast way to double check that these ports all work. All right, let's power this up. Oh, I have dead test plugged in. That is the problem. I have to reverse this thing. Diagnostic cartridge is that way. Powered up, there we go. Okay, that flash had nothing to do with the 64. That is the video capture stuff. It's a little flaky sometimes. All right, looks like everything is working, and then we already know that the sound test is working fine because we heard the music in the intro there. It sounded perfect. So if you run this diagnostic cartridge on your 64, I think I pointed this out before, but if you're new to fixing 64s, without the harness, you're gonna have a bunch of things that say that there is a problem. Don't worry about that. That doesn't actually mean there's a fault. It's just simply that the cart harness is not plugged in. One little tidbit that you may not know is down at the bottom, you'll notice there's two clocks. One says 1:10 a.m., one says 1:10 p.m. Well, the time keeps advancing. Those are clocks that are maintained inside the two 6526 chips on the 64. They're the I/O chips. One is for user port, one's for the keyboard, and they do a few other things as well. Those internal timers just show that the time counting is actually working and the chip is working. If the chip is totally dead or it's removed from your system, you're gonna get garbage. Instead of a correct time there, you're just gonna have like a bunch of random letters and numbers and it won't count down. So it's a really quick and easy way to know if one of your 6526s is bad on your 64 without having the diagnostic harness. So as we can see, it's already ran through multiple passes and everything is working. So this 64 is completely functional now. All that was wrong was that bad RAM chip. Now I haven't repaired a whole lot of these short boards before because they're very reliable. But if you're gonna have a problem on your shortboard, let me just tell you what I think are the most common issues. Definitely, I've had more than one of these where the RAM chips were bad. They're not always hot to the touch like this one was when you power it up. So don't rely on that. But if you feel one or both that are really hot, that means there's a fault. These chips don't get warm even after extended use of the machine. The other most common failure on this type of board though that will result in a black screen is actually this chip here, the 8701. This is a clock synthesizer chip, which basically helps the VIC-2 chip generate the clock signals used on the 64. Without that chip in there, or if this chip is bad, you're gonna have a machine that doesn't work at all. Luckily, there are modern replacements for this. You can buy them from various places. Here in the US, Jeff Burt sells them, I think. But just look online for 8701 replacement and you can find that. If you had an oscilloscope handy, you could actually check the clock lines on this and see that it wasn't generating clocks or they were not looking right, and that could help you figure out that that's the bad chip. A logic probe might also be able to do it, but because that can't really tell you if the clock signal is wrong, like the wrong speed, or it's glitchy or whatever, it's not ideal. An oscilloscope is gonna be your best bet for figuring that out. Luckily, I've only always seen this chip here in a socket, so it is easy to swap out if you're not really sure if that's the problem. But unfortunately, the RAM on these boards is always soldered in unless someone's already replaced it and installed a socket. So you're gonna have to remove the old chip, which is dangerous because you could lift traces. I'm not sure why I didn't demonstrate this, but I should have used some cutters like this to just cut all the legs. So you remove the black plastic package and you're just left with the legs in the board. And then you just take your soldering iron and you heat up each one, use tweezers, and you pull them out of your board gently. That is the safest way to remove a chip from a board, even safer than what I was doing using the Hakko desoldering iron. Anyhow, Michael Orange, thank you very much for sending this in. I'm just gonna put that there and put fixed. Maybe I'll put the date here. I'll just put 12/20/21. And yeah, it was the bad RAM, U10. That was it, the only fault. All right, here is our next victim, or sorry, next machine we're gonna be trying to fix. It says DC. That must have been the viewer, I think, who donated it, but I don't remember your name. But I wrote black screen with and then with the dead test, sometimes flashes, corrupt test screen, loads of MOS chips. And I'm talking specifically about the DSLogic that Commodore used to replace the chips when they couldn't get like a 74LS whatever. They made a version themselves and they are super bad quality. And I put hot U14. That's probably one of those MOS chips. So we can definitely suspect that there's gonna be some bad MOS logic chips on here. So let me open this thing up. So this one, just like the last one, has the 8701, and that can fail and of course cause a complete black screen. The PLA of course can fail and cause a black screen, although take a look at that. This one has a PLS 100. So this is a PLA that is very much like the 82S100 that was first put into this machine. This is not made by Commodore, and I think these are very, very reliable. So it's very unlikely that this is actually a problem. It seems like this motherboard's a little bit of a part special because that PLA is from 1987, and this could have been a replacement that someone installed. 1985, 20th week, 1983, 16th week, then we have 84, 84, 84, 24th week. And then we have one of the 6526s from the end of 84, another one from the middle of 85. The fact that these are all socketed, you never know, someone might have been swapping parts around. And we look at the RAM and the other soldered ICs here, they're all from around middle of the year 1984. So that's probably when this machine was actually made. So I think it's unlikely that things from 1985 were in here originally. These were probably installed after the fact. Notice the RAM is all Motorola branded except for this one IC here. That's almost certainly factory. Commodore did stuff like that. They just used whatever they had on hand. Probably was like a big bin of RAM chips and they would just grab them and stick them in. And I guess there was just one of these parts mixed in with these other Motorolas, and you're just gonna see lots of random stuff on these boards. These are the MOS chips I was talking about that often fail. These are normally 74LS something or others, and these are the cheap, crappy MOS versions of them. And then this is one as well. And then this chip here is in the socket. We'll have to look on the underside to see if that is original, but it's from 1983, which is before this machine was even made, so it's kind of unlikely, although Commodore was known to put sockets on boards too, and then whenever they had the chip in stock, they'd actually install it. So that was their way of getting machines mostly built, and then they could finish building them by putting the chips in that were still empty on the sockets. All right, so next step, get this thing out of the case so we can take a look at the underside. This does have an RF shield that is soldered onto it. Looks like this plastic standoff broke on the case. It did indeed, it's missing entirely from there, so it's stuck on the bottom. That's what happens. If you have this happen, Jeff Burt has like a little kit you can buy. He has new standoffs you can buy and you glue them onto your case, and yeah, you can repair that stuff. For removing the RF shield that's on the bottom of this thing, one way you can do it really easily is you just use some cutters again, like these, and you just snip it off around the edges. And I know people hate it when I do that. The thing is, there's a lot of thermal mass between the ground plane on the motherboard and the shield itself, so you have to use a soldering iron that is able to actually quickly melt and take care of the solder. So if you want to take it off though, you just melt the solder that's on there with something with high thermal mass, and then use like a pick or whatever, like I have here, to just scrape or lift it off. There we go, and bend that out of the way. Please keep in mind that in the US, this RF shield was installed on all 64s, but in other parts of the world, it wasn't. So it really has no bearing on the actual functionality of the 64. It was purely for FCC regulations in the US specifically, and maybe some other countries that required the installation of it. But plenty of this exact motherboard design in other parts of the world wouldn't have it at all. So if you take it off, you're not going to impact the capability or the functionality of your 64 or the reliability. Of course, you'll make some people mad because they feel like it should be there and et cetera, et cetera. But ultimately, in this day and age, we have so many things that cause interference, like LED light bulbs and stuff like that, that your 64 that you turn on occasionally is just not going to make much difference to the overall RF noise spectrum. This isn't 1983 or 84, where we didn't have like everything under the sun with a switching power supply. All right, so that is off there. There it is. Now there's still, okay, I was gonna say it was still connected right here in between the ports, but I couldn't reach there with the desoldering iron. So that is off, okay? So that goes bye-bye. All right, now that we have the bottom exposed, let's take a look what's been worked on this machine. All right off the bat, this right here has been replaced, which is this chip here in the socket. So someone took that out, whatever went bad, and put a socket in, so thank you very much for that. I'm gonna say that nothing else has been worked on at all on this machine. And by the way, I just wanna mention something that I think some people have pointed out before in comments. See this wrinkled appearance to the traces that are on this thing? That's not a failure or a fault in any way. Like, that's the way this has been since it was made back in the old days. The manufacturing techniques for large PCBs just wasn't the same as what we have today. And certain companies, when they manufactured the 64 PCB, you got this sort of wrinkled effect. And it's been like that its entire life. So don't think that your board is like falling apart because you see this wrinkle stuff going on. It's been like that since it was made, and it's completely normal. Now, it's interesting, it's not on the top at all, and it's only on the bottom. And I think the engineering nerds from the old time can probably explain why it's usually on the bottom more than on the top. But I do know for sure that it's not a sign that this board is dying or anything. It just means that it was just made that way. This particular one was made in Hong Kong. It says made in Hong Kong there as well. Who knows that maybe that plant always made wrinkly traces. There's some wrinkling going on the top here as well, like here and around the VIC chip. But like I said, totally normal and not a problem. So this particular revision of the 64 motherboard is right here, 250425. And a quick Google, and it brought me to this page here, and it's an 8-pin board. That means the video port has 8 pins, and it has the oscillator chip, or the 8701, that's this here. So instead of the circuitry that used to be on the 64 to support the oscillator, it now just has that one chip, which is driven by the crystal oscillator. I have a mark on this IC here, which is U14. It's silk screened on there. And we look here, U14 is a 74LS258 multiplexer. So it has to do with the RAM access, I think. And there it is, there's that multiplexer. So it's hooked up to various address lines on the machine, specifically for the, looks like down through this latch to the character generator ROM and also to the VIC2 here. So we're gonna get all sorts of issues if this thing is not working properly. Okay, so the oscilloscope is ready and the machine is powered on. I'm just gonna quickly go through all these pins and look for anything that looks out of the ordinary, like for instance, voltage levels that are out of kilter, like they're in the middle somewhere. So far, these all look fine. Okay, that looks wrong. So we're gonna keep going for a sec. Okay, this is all fine. The one that looked bad was pin 4. Okay, good. Yep, that's fine. That's not doing anything. Oh, there we go, I just didn't have good contact on it. Okay, that's good. Yep, that's fine, and that's gonna be voltage. Okay, so this pin right here is pin 4. All right, so I'm on pin 4 here, that doesn't look right, and that is also connected right here to this IC, which is U13, which, surprise, surprise, is another MOS IC. It's this one right here. And I'm pretty sure that this IC that's been replaced is also the same IC part as that, which is 74LS257. These are both 257s. And you know what? That chip is not that hot, but that one is. Let's check the outputs of this. So pin 4, which we already know is bad, 9, 7, and 12. It's really burning my finger touching it there. All right, so 1, 2, 3, 4. So we know that's gonna be not looking good. 6, 7. There's 7. That's not right. Look at it, it's all high. That's really not right at all. It's all way up there. 9. Okay, 9 doesn't seem super bad. 10, 11, 12. Okay, 12 looks fine. Okay, so 2 lines on there look really bad. I'm gonna turn the computer off. It's obviously causing a bus conflict or something. So we're gonna pull that out. The fact that it's really hot, dead giveaway there's a problem. It's you know, it's shorting these 2 chips together there. They're both trying to drive it at the same time probably, and that's causing a problem. So I'm gonna mark the board right there, and we're gonna take that out. Oh, look at that. I didn't even have to use hot air to get this chip out. That just came right out. Nice. All right, socket is installed. 74LS257. Let me find one of those. Okay, I found this in my part, 74LS257 from 1979. Nice and old. Because it was in my parts bin and completely untested, I am gonna do a quick test of it first on the Chip Tester Pro here. The pins on this IC are extremely mangled. Don't know where I got this from. It's definitely pulled out of some piece of equipment. And yes, you may be noticing that this thing looks extremely good now, and that's because this is an OLED screen that was donated by a viewer for the chip tester, and look how amazing that looks. Anyhow, 74-257, there it is. Let's run the test. Uh-oh. This may not be in the socket all the way though. But this also could be a bad chip that was removed out of something. Oh, no, there we go, it's good. It was just not in there all the way. The pins are really dirty on this. So anyways, we know it works. I mean, we can test this MOS one just for fun. I guarantee you it's gonna fail. Right there, chip failed. In fact, let's just move that around in there. Try that again, 257. Right there, dead. All right, so let's install this new part, well, new old part, into the board here. Now, there may be other faults on here, right? I mean, there's all these other MOS ICs. They're so flaky. So, turn the power off. Let's plug this in. Let's switch back to HDMI and power this on. What are we gonna get? Why are we not seeing anything? How about because I don't have the cable plugged in? Oh, look at that. It's working. That was it. That was it. Why did I write U14 on here? Hot U14, when U13 was clearly the problem after poking around with the oscilloscope. Okay, should we just jump right to this? Or should we try the diagnostic cartridge? Why don't we just go right to a dance party? All right, keyboard is connected. Make sure the speaker's turned up. This cable does not work very well, I have to say. All right, there's a pretty noisy Sid chip in this machine. We have a bad Sid chip. Let me do a direct capture so you can hear that. All right, well, it's weird because it sounds pretty normal there in that part, but I'm gonna go back to a direct capture here, and then we'll start again so you can hear the intro to the song, which sounds really screwy. I'm gonna say that all of the voices are working, but some of the modifiers or whatever, the things that change the way the voices sound, the filters, that's what they're called, filters, is not working correctly. So when it uses those particular filters, that channel is really quiet and muffled sounding. So let's run the Sid tester and that should reveal the problem directly. All right, well, I bumped the machine when it was running, and now we have this garbage here. All right, I pushed down on the multiplexer chip, the one with the dirty contacts there, and it started working again, and the machine is still running. So I have a feeling that chip must have really bad legs or something, so I may need to replace that. Okay, so I think the filters, everything sounded like it was working, but I think the filters aren't working correctly. I need to grab another SID chip and do an A/B comparison just so I can hear exactly how it sounds versus this one. All right, I placed my known good SID in there, and before we run the test again, I'm just gonna take out this other multiplexer here, and I'm going to just deoxit the socket here. This is a really cheap single wipe socket, whoever installed that one, so this could be flaky as well. And it might well be the one I just installed as well. So we'll add some deoxit to this brand new socket, specifically not because of the socket, it's because of this IC, which has very gnarly legs. You know what, now I think about it, I think I found this chip in some old foam. The anti-static foam, when it gets old, it actually starts to degrade and it corrodes the legs. And I'm pretty sure that's what happened to this IC. I can just see just some reminiscences of it. Let me grab my little fiberglass brush thing and let's try to clean off these legs a little bit. Needle nose there. Oh yeah, this is making a big difference. It is nice, it's making them nice and shiny. All right, so that should help a little bit, I hope. Word of caution, if you have old ICs that have been sitting around in anti-static foam for a long time, you should take them out. It definitely can damage them. The foam starts to get gooey and really hard to get off the legs. And the way I got it off is actually soaked all the chips and that foam in 99% IPA, which had the effect of sort of disintegrating all the foam. Okay, the machine is still working. All right, let's see here. Adrian's tools, Sid Tester. Nope. We still have an issue there. It's interesting. Which IC is it? Okay, that crashed the computer. Which one is it? It seems to be worse when I run the Sid Tester. Okay, is it the top chip? Or is it this bottom one? Or is it neither? Okay, I think it's the bottom one. Yeah, it's this one. When I push on it in a certain way, oh, maybe not, maybe. Or is it this one? I don't know, this is hilarious. No, I don't think it's the top one, because that's not doing anything, it's this bottom one. I'm gonna still take that socket out. It didn't look good, it was not well put in, and it's a single wipe, and I just hate the single wipe type. All right, did that come out? It melted it. Nope. I gotta say, I really hate removing sockets. They just don't come out as easily as ICs do. I don't know why. So I'm just gonna melt the crap out of this thing. Get this out of here. There we go. There we go. So removing that left two legs behind, so not a big deal. There they are, they just popped out. I pushed them out with the desoldering iron. All right, since I didn't remove this the first time, I'm gonna inspect. Oh, this is ugly. I just wanna make sure that nothing is ruined. It's a little bit of a mess. I gotta clean this up here. All right, it's okay. Nothing is damaged on the top side. Okay, all right, everything on the bottom looks okay as well. All right, we have a little bit of one of the holes. It's not quite empty all the way. And actually one of the vias is damaged a little bit. Let's see if I can get this thing in. All right, no problem, it's gonna be fine. So we put that there to hold it in place. Okay, socket's in. I'm gonna use the loop here to check for any bridges. It's kind of ugly, but it looks totally fine. All right, there we go. I just popped in the old chip in the bottom one, but they're both new sockets. So hopefully we are fully operational now without any kind of glitching or whatever. Make sure those pins are out of the way. All right, first power on. Will it work? Black screen, nope, there we go, it's working. Just the glitchy cable, so that is not related to this machine. Let's go back to Sid Tester now. Okay, there it is. I think I mentioned early on I like this revision of motherboard. The thing I like about it is it's really, the picture quality is just really clear, and it has very minimal jail bars, and that's what I love about it, minimal jail bars. All right, Adrian's tools, Sid Tester, let's do the old bump test. Look at that. Okay, ignore that it's getting darker, that's the cable. No more glitching when I bump the board. That socket was bad. Oh, someone's repair was foiled by a bad socket. All right, here we go again with the all tests. I'm just gonna listen and report back if I hear anything. Actually, I think it's the filters is the problem. Let me listen to that again. All right, now with that heard, I'm gonna swap back to the Sid that was in this machine. And let's listen to what that one sounds like. I mean, whatever's wrong with this Sid is very subtle. Okay, listen how noisy that is, wow. Okay, here we go, same test. Yeah, these filters do not work properly. Gotta say, that's kind of a strange failure mode. I haven't heard this particular problem before. Chip seems to be working other than being noisy, but those filters are not sounding right at all. So I'm gonna write a big M on this Sid chip for marginal. It's good for testing, but I think those filters not working properly, it's gonna make some things sound fine. Like I'm sure that the little ramping tones in the diagnostic cart will sound fine, but things that really push the Sid chip to the limit are not gonna sound fine. And I heard that as soon as the Donkey Kong arcade music started with that 8-bit dance party intro. All right, for the final test, we're gonna run the diagnostic harness on this machine. I'm fully expecting pretty much everything to work on here unless there's some other hidden problem like one of the 6526s are bad. Luckily, they're all in sockets, so there won't be any issues if I have to replace one of those. There we go. Looks like it's almost done. Yep, it's done. And here's the Sid test. And that sounds absolutely perfect. No problems with that Sid test in here. And that's why this is not a good diagnostic to see if your Sid is working. You really need to run the Sid tester that I was running there and make sure that you compare the way it sounds to a similar revision of the Sid to a known good one. So if you look on the internet and hear a good one, then compare it to yours. But you have to compare 6581 to a 6581 or the Sid that's in the shortboard to the same Sid that's in the shortboard. All right, so this board passed all its diagnostics, so it is good to go and that glitchy problem is fixed. So that is another repair complete. So I'm gonna write out a new note. I'll put DC again because I don't know what that means. We had a bad U13 and we had a bad socket at U25. And those are the bad parts right here. So yet another bad MOS chip, of course. And just like on the last machine, things were overheating. So would you feel hot chips? Of course, this chip was also kind of warm, but that chip was really hot. So that really, again, was the giveaway. But let me tell you, I've had plenty of these MOS TTL Logic chips go bad, and they weren't hot like these ones. So that's not always a dead giveaway. Also, one chip that's shorting can cause another chip to get hot, although usually you're gonna have the chip that's shorting also be hot. So maybe you have two hot chips. Anyhow, once again, the oscilloscope came in really handy for troubleshooting and fixing this. The bad chip there had 2 signals on it that looked all out of whack, which was sort of the giveaway that that was the bad chip and not this one over here. Is that the one I'm pointing to? Yeah, this one right here. So I think that is going to be it for this little mini repairathon on these 64s. I do have a box down there on the floor with a bunch more to work on. So there'll be more coming. I think people enjoy these videos. I mean, even if you're not into the 64, just the art of troubleshooting is still fun to watch. And generally these types of techniques apply from one machine to another, right? So it's useful, right? Anyhow, if you did enjoy this video, I would love a thumbs up. But if you didn't, you know what to do. You can hit that thumbs down button. Subscribe if you haven't already. Check out the second channel if you haven't already. And I want to give a big thanks to my patrons whose names are scrolling up the side of the screen. If you want to become a patron, you can do so as well. And I guess that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye.